Hello everyone, welcome back to my channel. Today I'll be covering one interesting topic which are SQL and window functions and why do we need them. So let's say imagine you are in an SQL interview and the interviewer asks you to find the highest paid employee in each department or calculate running total, rank employees by salaries. So these are quite difficult questions, but here's the interesting part. These all can be solved using window functions. So in this video, I will show you how window function works and then we'll proceed further on different use cases. So I'll introduce you to the data set we have. We are creating a table known as employee, which has different employee ID, employee name, department, salary, joining date, and city. And here we are inserting a few data for our use case. Now, if I do select star, you see these, there are 12 rows of data in the table. So most of the questions can be solved by group by, but let's say someone asks what is the average salary in each department. So what everyone will do is will write a simple group by clause where you group by on the department and you get this output. You can see that the output is now grouped by department. So IT has 86,666 average salary and so on. But we don't have the employee's name here, like Rahul, Aman, Neha, those names are not here. So what if we want to get those names? So let's say business comes with a requirement that we need to show the department average salary using this data set. This cannot be done using group by. So there is when we need to add a row on all the lines, a new column, then we use the window function. So window function has many important parts. First, we'll learn about the over clause. So what does the over clause do? It defines your window. So in this case, I'm writing select employee name, department, salary, and average salary over, and I'm giving the name alias as company average. So I haven't defined the window as such. You have to take the window as the whole of the dataset over is blank. So now when I run this, you'll see that it has generated a data set with the name employee name, department, salary, and a company average, which has the same value across all the 12 rows. So this is what the over clause do. It creates a window. In, but in this case, since we are not passing anything inside our over clause, it creates the whole data set as the window. So in the last chapter, we learned that the group by reduces the number of rows and the over clause keeps the same number of rows. But how does it know that we have to calculate over this subset of data? So let's understand over clause. So you notice here all the employees have the same company average because we didn't pass anything inside the over clause. It took the whole of the table as our window. So the entire table becomes our window. So if we don't specify anything inside over clause, SQL assumes the entire result set in the is the window. So the next thing is introduction of partition by clause. Let's say I don't want on a company level, on the whole of the table level. I need what's the average on department level or what is the average on employee level. So with that, we need to know about the partition by clause. So in order to understand that, we'll write a new query where we are doing select employee name, department, salary, and since we need average salary and over, and this time we have something inside the over clause which is partition by department as department average. So let's say when we run this, we get the output. Now if you see the output, this was when we didn't define anything inside over clause, and this is the output when we define partition by as partition by department. So now when we have written partition by department, the SQL query treats every department as a window. So finance becomes one window, HR becomes one window, IT becomes one window, and sales become one window. So in a nutshell, partition simply means divide the data into smaller windows. So let's say we have a clause to find out who earns the maximum salary in each department. So here we have given the partition by on the department and the max of salary. Now we get highest salary. This is 95,000 is the highest salary, which is Ankit. 75,000 is the highest salary in the HR department, which is Priya and Mega. Similarly, we can use it to find the minimum of salary, average of salary, and so on. So until now, we didn't care about the sequence. It's simply grouped by rows. But what if order matters? Example, running total, running salary. Then is the time when we have the order by clause also. So let's say if I write this query as select employee salary, comma sum of salary over order by salary. So now what this does is it evaluates something row by row. So now since I've given sum of salary over order by salary and without having any ascending or descending, it takes by default ascending. So now you can see that the output is sorted by salary ascending. So salary 58,000 comes first, then 60,000, and then we have the running total as defined in the over clause. So over decides the entire table, partition by creates the windows, and order by defines the. So now we learn about the row number function. So let's say you have a business requirement to assign rank to employees in the descending order according to the salary. So we write an over order by salary descending as row number clause. When we run this, we see that row number generates a sequential incremental number from 1 to 12. Now the issue with this is even if we have two-person with the same salary, let's say Aman and Neha have the same salary as 85,000, they will still have the different row number to them. This is how row number function behaves. So in order to overcome this duplicate ranking, we can use the rank function also. Now let's say if I run this, check the manual. So if you see now we have the 12 ranks here also, but if you see the people who have the same ranks, they have the same salary as well. So 85,000 salary Aman and Neha both have, and they got the same rank 4. But if you notice, the rank function skips the ranking. So since we have two positions on 4, it skipped the 5th rank and allotted the 6th rank to Megha. So this is the how rank function. So simple use case for rank function is, let's say in Olympics, two people finish first, then they would be given the same rank, and the third person would get the third bronze medal. Now the next is dense rank function. So now when I do a dense rank, you see that the ranking has reduced by 1. Earlier we used to get uh, 12 rankings, now we get only 11 rankings. That is because the dense rank doesn't skip ranking. In the ranking function skips ranking, but the dense rank doesn't skip ranking. So in this case, if you see Aman and Neha have the same rank 4, but Megha gets the rank 5 as compared to rank 6 in the rank function. So dense rank function doesn't skip ranking. So to sum up this, we will compare all the three rank, row number, and dense rank functions together. So if you see, we have the complete picture how rank works, how row number works, and how dense rank works. So in row number, you see that it assigns the incremental value whether we have the same value or not. So it goes from 1 to 12. In the rank, you see that the same person who has the same rank, sorry, same salary, they get the same rank, and then the next ranking is skipped. So after 4, we got 6 because at 4 there were two employees. In dense rank, no ranking is skipped, and if two particular employees have the same ranking as 4, the next one gets the ranking as 5. So this is the difference between row number, rank, and dense rank. Now let's say we have a requirement to rank the employees in each department. So remember, department becomes a window. So we now have to introduce the partition by clause. So we just introduce partition by department. And now if you see, the ranking starts whenever the department changes. So finance becomes one block, one window. HR becomes one window, IT becomes one window, and sales become one window, and each has different rankings starting from 1. So in this case, if you see in the department finance, Ankit has the highest salary and Ramesh has the lowest. So 1, 2, 3. And then since the department has changed, we again start from rank 1. So very interesting question can be to find out the highest rank salary uh, employee in each department. So in that case, we'll do this. The department window, we'll define the window on the partition by department, order by salary descending, and then with the help of the CT clause, we'll be able to find out the highest rank employee by giving rank is equal to 1. So if I run this, you see Ankit in the finance department tops with the highest salary. Megha in the HR department tops Rahul and Pooja. So these are people who have the rank 1. So let's say the interviewer asks rank 2. So just we'll give the RN as 2 because we have calculated row number here. So we'll run this, and these are the second highest salary department wise. So whenever you are solving a ranking problem, you need to ask two questions. First, should equal values receive the same rank? Second, if they do, should the next rank be skipped? And then you decide what to use, such as row number, rank, or dense rank. So in the last chapter, we learned about how we use rank, row number, and dense rank functions. Until now, we were not concerned about what is my previous value, what is my next value, how is my previous value affecting the next value. We were not worried about those. So now we'll look into those values such as running total, lead, lag, first value, and last value. So let's say we need to calculate running total. So running total is when you add up the salaries one by one. So 88,000 is the first salary. Then we add 70,000. What will be the total of it? That should come here. So let's say if I run this. So here we get the running total of the employee of a company. So if you see here, we have given sum of salary over order by salary as running total. Since we didn't define any window, it took the whole of table employee as the window. So let's say a payroll team is processing your salaries, and they want to know when do we cross 6.3 lakhs of salary. So in that case, they would just sum up this running total, and then they see that this is the employee. Aman is the employee where we cross the payroll of 6.3 lakhs. So if you see, Deepak has 58,000 salary, then Karan has 60,000 salary. So the running total becomes 1,18,000 and so on. So this is how you calculate the running total. So just an interview tip here. Whenever you hear words like running total, cumulative sum, balance till date, or year to date, think of sum over order by. What is the thing that you're trying to calculate? Salary in this case. So let's say instead of the running total, management wants the average salary up to the current employee. Let's say the management wants to know what is the average salary from Deepak to Pooja. So we will use the average clause in this. And when I run this, you will see we have the running average as well. So Deepak was the first employee. He has 58,000 salary. So the average becomes 58,000 because he is the only employer. Now we have Karan who has the salary as 60,000. So when we add these two and take the average is 59,000. So this is the running average. So the HR department can see, like when we process all the records, all the employee salaries, the average salary is around 75,000. So this is how you calculate the running average. So in the first example, we saw how to calculate the running total. In the second example, we saw how to calculate the running average. You just have to change the clause as sum or average, whatever is your business requirement. So next is a very important case where we want to understand how is each employee's salary compared to the previous employee's salary. So in that case, we use the function lag. So we'll write the query as lag, what we are calculating, lag of salary over order by salary. So now if I run this, you'll see that for every employee, it has given me the previous salary. So for Deepak, there was no salary, so it has given me null. For Karan, the previous salary was of Deepak, so 58,000 comes here. For Pooja, 62,000 is the salary, and the previous salary was of Karan's, which is 60,000, which is comes here. Now, once you have this column, you can easily calculate the difference between these rows. So that is helpful of calculating the difference in the two salaries, the lag function. So let's say business asks you how much salary has increased over per employee. So you write salary, which is your original column, minus the lag of salary as the salary difference. So now when you run this, you see you get the difference in salary also. So Deepak's salary is 50,000. Since there is no one ahead of Deepak, the salary difference is null. Now Karan, coming to the second employee is Karan. Karan has 60,000. The previous salary is 58,000. When you subtract 58 from 60, you get the difference as 2. So you can calculate the difference of salaries. Similarly, if you want to calculate the lead salary, what is the salary ahead, we can do it using the lead function as the next salary. Next very important use case is the first value function. So when you've passed first value instead of lead or lag, you get the first value of the salary, which since you have sorted salary by descending, you'll get the highest salary in that window. So if I run this, you see the highest salary is of Ankit and that salary is assigned to all the rows since we have not defined a window. So you can use first value to calculate the highest salary also. So in this case, now we have defined the partition by clause. What is the partition? Department. So you'll get the highest salary in each department. So in the finance department, Ankit has the highest salary and this has been assigned to each row. Similarly, you can use the last value function to get the lowest salary in this case. So if you see the lowest salary, sorry, you have to use the ascending clause. And then you get the lowest salary. So let's say now we are talking about a real interview question where we have the requirement to find employees whose salary is greater than the previous employee. So in that case, we can use the lag function to calculate the salary, previous salary, and then we can do salary greater than previous salary. So if I run this, you get these are the employees whose salary is greater than previous salary. So in case of Karan, you can see that the previous salary was 58,000. His current salary is 60,000. So we got this in the output. So now we have covered all the different aspects of the window functions: row number, rank, dense rank, running totals and everything, league, add functions. Now we'll look at some interview questions. So let's say you have been given a table, employee table, the same table that you were using, and they have asked which is the highest rank employee. So you would write the query as select star from row number over order by salary descending. So you have these rank assigned to each row. Now, if the ask is to calculate the top rank salary, you will just wrap it up inside a CT and then use the where rank is equal to 1. So you get as Ankit as the highest salary. So let's say you get another question, which is the second highest rank employee. Then you get the answer as Rahul. So now let's say the requirement is find the top three salary, highest salary. No, in that case, we'll just change from row number equal to 2 to less than 3, equal to 3. So then you will get the top three salaries for that particular table. Now another interview question can be to find highest employee salary in each department. So what changes would you done? You would add a window which is department. So partition by department, and then assign a row number to it, and then we use the row number is equal to 1 to get the highest employee salaried employee in each department. So you can see finance has Ankit, HR has Mega, IT has Rahul, and Pooja. Sales has Pooja. In same case, if they ask which are the top two in each department, you can just give top less than equal to 2. Okay, we have given a space. So now you can see that for each department we have the top two highest salaries. So finance have Ankit and Sneha and so on. So just the change is that we calculate the department partition by department and assign row number less than equal to 2. Very interesting use case is to calculate the employees who are earning more than the department average. So for average, you have to calculate average salary over partition by department. And then you can, since you have one row as department average, you can now calculate where salary is greater than department average to get the list of people who have the salary as greater than as the department average. So let's say you get a requirement to in an interview to delete duplicates from a table. In that case, you can use the CT clause and then use the delete to delete where the rank is greater than 1. So essentially, you are keeping the rank 1 and deleting all the employees. So next, I have prepared this cheat sheet where you have can figure out what to use. So if you need unique numbering, use the row number function. If you need a competitive ranking, use the rank function. You don't want to skip rank, use the dense rank function. To calculate the previous row, you need to use the lag function. The next row, lead. Running total, you can use the sum clause over the entire table. Department average, average over the partition by ID. Highest salary, max of and then divided by the partition by salary. And the second highest salary, you can use the dense rank function. So this is it about the window functions. I hope this video was very helpful. If this video was very helpful, please like, share, and subscribe. Follow for more interview ready questions and answers. Thank you.